Welcome back, everybody. Mr. Martin here. We are on 8.4. We are going to talk about writing piecewise functions. Now, in the last section, we learned how to graph them. This time, we're just going the other way around. So we're going to look at these graphical representations, and then we're going to write these along with our restricted domains. All right, so I want you to recall writing the equation of a line when given a graph. Okay, this is something that we've done before, so I want you to pause the video real quick and then try writing this on your own. Come on back, we'll talk about it. So pause the video right now. All right, welcome back. So as you can see here, I actually wrote this out already, but remember what we want to do is when we have the graph of a line, there are a few things we can identify, and that is the slope. Okay, we can identify this graphically, so remember, find actual points that are on the graph. Don't use points like this because it's not actually in a definitive point. You would kind of just be estimating using that area right there. But here at -6, 1, I have a solid point or a accurate point, and then again here at -3, 3. So what I did from this point to this point is I went up 2, meaning that is a +2. I went to the right 3, meaning that is a +3. We have a positive graph right here. So this is my m value. Remember, we have y equals mx plus b. Remember, this is the slope-intercept form of a line. And then I also found my b value, which is where the graph crosses the y-axis. Okay, and that was at +5. And then all I'm doing is simply plugging these values into the variables that are in that slope-intercept form. So I just replaced the m with the 2/3, and I replaced the b with the +5, making this the equation of my line. Okay, so it is important that you guys remember how to do this because you are going to need to know how in order to actually write that piecewise function. All right, so let's jump in. We got a couple examples here. This first one wants us to use this graph. It says write the piecewise function for the following graph. And I put this notation on here because if the y-intercept is on the graph, okay, it is a little bit easier. It requires less work. But it doesn't necessarily need to be, and you'll see that in the next example. But what we can do when the y-intercept is on the graph, it is really simple. All we need to do is extend our graph, and we can see those values as they are. So the first thing that we would want to do, remember, we are writing this in function notation. So we have f of x, we have our equal sign, and then remember we have this nice big squiggly bracket to include our functions. So we want to read this from left to right. So if we look at this first line right here, we see that it is a horizontal line. And if we were to extend it, let's do this here. If we were to extend this line, it would cross at -7 on the y-axis. So that tells us that the equation of this line is -7. Okay, and then we have that comma. So what I want to do first is we're going to write each of these functions first, and then we're going to go in and do the restricted domain. All right, so this one is already crossing the y-axis, so we can see the y-intercept easily, and that is going to be a +1. So we know we're going to have something here as +1. That is our b value. Now we want to find the slope, so remember we would want to start with a nice even point, and that looks like this one here. And then as we start tracing down, it looks like we have another good one right here. So we would want to, just kind of come down here and then come across over here. And we can take a look at these values. How far did we go down? Well, we went 1, 2, 3. So if we went down, that's going to be a -3. And then we went to the right 2, so that is a +2. And remember, it is always y over x, rise over run. So we went down 3, so that is our numerator. We have this negative out front. We have our numerator of 3. And we went to the right 2. Remember, left to right is your denominator. And then we always put our x. When we have a slope, there will be an x right there. Let me actually make this look nicer. So we got negative 3 over 2 x, and we said plus 1, and then we can separate that with a comma. Alright, so now this next graph, it actually right now is not cutting or crossing the y-axis, and that is because of the domain that it's in. But what you could do is you could simply use the slope that you have. Let's actually write that out first. So it looks like we're starting here, and we're just going down here and across here, very small slope. So it looks like we are going down 1, which is a negative 1, and we are going to the right 1. So this is a negative 1 over 1, which is just the same as negative 1, and we actually don't need to write the 1. We can just write negative x. Okay, but then we might want to trace back to see where it would hit on the y-axis. So if we were going down 1, right 1, the opposite would be up 1, left 1, up 1, left 1. So it looks like it would cross there, and if we extended this graph out, it would look something like this. So it is actually crossing here at positive 4. So that is our y-intercept at positive 4. And then we have our comma. Alright, let me go ahead and remove this just so we can see all of our values. Let's get rid of this. Get rid of this. And get rid of these. Alright, now we want to write our restricted domain. So for our first graph of negative 7, well, we have a open circle here, so that means we're going to use a parenthesis, and it looks like we're taking all of the x values to the left of negative 4. So these numbers are getting smaller, so we know that all of our values are less than negative 4. Okay, and we go on until negative infinity, so we can represent this using only one endpoint, which is that negative 4. Okay, and then our next one, we actually have 2 endpoints, so we are within an interval. And if we look at both of our dots here, these are both solid dots, so we're going to need that less than or equal to. So remember, this is a compound inequality, so x is in the middle of these two values, and then we just simply look, what are the x values? We have a negative 4, and we also have a positive 2. Alright, and then our last one, we got these 2 open dots. So we are not going to use equal to's. We just have the inequality signs of less than and greater than, and then we find our interval for the domain, so between 2 and 6. Alright, looks good. Okay, this is our finished product. So if you have all of the y-intercepts, it's easy to just trace that graph and then find that y-intercept. Alright, in example number 2, okay, so this third line here, you can see this one crosses the y-axis, so we have a y-intercept here. But if we look at these other two, okay, are they going to all cross the y-axis? It might look like, but probably not this one, and probably not this one. So we do need to do a little bit of additional work, and that is where our y equals mx plus b will come in handy. Okay, because all we are trying to do now is find that y-intercept, and I'll show you guys how to do that. Now the first thing we want to do is find the slope of the line. So one easy way to do that is to go from one point to the next, and we can do that going from here, -6, and then going all the way over to here. And then let's count our values. So we went up 1, 2, 3, 4, 5, so that is a positive 5, and we went 1, 2, 3. We went to the right 3 times. So right now for this first line we have an m value of 5 over 3. Okay, and then now we are just looking for the b value. So what we need to do right? If we look at our slope-intercept form, what variables do we have? We have a y, an m, an x, and a b. So if I am trying to solve for b, if you remember solving equations for two variables, we needed to find at least one of those values. So here, if we have 4 variables, we need to find 3 different values. And we can do that by using a point on the graph. So I'm going to use the point -6, 0. So -6, 0. So now I have all 3 of my values to help me find b. I have my m, I have my x, and I have my y. So we're just going to plug these in. So 0 will go for my y. And then my m is 5/3. And then my x is -6. And then I have this plus b. So what I'm going to do now is solve for b. So I would multiply these two. -6 times 5/3 is going to give me -10. And then I have my plus b. But then I want my b to be completely by itself on one side. So instead of this -10, I got to add 10 to both sides. And then I get 10 is equal to b. Okay, so now I have my m and I have my b. I can write this in slope-intercept form, which is y is equal to my m value, 5/3. I put my x out front, and then I have my b value of +10. All right, so that is our first one. Let's go ahead and do our second one. I'm going to split this screen right here. All right, so our second slope we need to find. So we're going to do this. Oop, wrong one. Might help if I use this. All right, so we're going to go from this point to this point. And it looks like we went up 1, 2, 3, 4. So we went up +4. And then we went to the right 1. So here I would have a m value of 4. Okay, and then I'm just going to choose to use this point. Remember, any point can work, but you want to make sure that you are using accurate points. Don't use something that doesn't touch one of the corner of the boxes on the grid here. So we're going to use this value here, which is -2, 7. So I'm going to write that down, -2, 7. I'm going to label this as my x and my y so I don't forget. And I'm going to do the same thing that I did here. I'm going to plug this into my slope-intercept form. So I have my y value, which is 7. That's going to equal my m value, which is 4. And then my x value is -2. And then I have my plus b. So 4 times -2 gives me a -8. And then I have plus b. And then I need to add 8 to both sides to get b by itself. And I get 15 is equal to b. And then now we can write this in slope-intercept form. Y is equal to my m value of 4. I put my x out in front. And then I have my b value of +15. Okay, that is my second equation. All right. Let's go ahead and block this off. All right, and then the third one I do not really need to do. I just need to find the slope because I do have a y-intercept of -3. And I can do that by tracing down from here down to here, and then down to here. So let's count. We went 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9 because we went downwards. And then we went 1, 2, 3 to the right 3. Now, if I have -9/3, is that going to be my slope, or is this something I can simplify? Well, -9 divided by 3 is -3. So this is going to be my actual slope. Remember, if you go from endpoint to endpoint and it is something you can reduce, please reduce it. This is going to be your actual slope here. So let's go ahead and write our piecewise. We got f of x. Okay, we need our big squiggly bracket. Okay, and our first equation is 5 over 3x plus 10. We have our comma. We have 4x plus 15. We have our comma. And then our last one, we have a slope of -3. So we got -3x. And then a y-intercept of -3. Okay, and then now we need to go and do our domains. So from our first function, right, we got between -6 and -3. So we got a -6, and these are solid dots, so this is going to be less than or equal to, less than or equal to, and -3. On our next one, we are between -3 and -2. So we got -3. This is an open dot, so we don't want the underline. And then we have a solid dot, so we want the less than or equal to, and this is -2. And then last but not least, we are between -2 and +1. So -2 has the open dot, and then +1 will have the less than or equal to. And we are complete. So this is a fully written out piecewise function for the graph to our left. All right, so this might be what you need to do on some of these graphs if that y-intercept is not accessible on the graph based on the numbers on your axes, but it can easily be found by using that slope-intercept form, finding a point, and identifying your slope. All right, moving on to the next one. Example 3, we've done something like this before in 8.2. We are just doing it with a piecewise function again, and we just want to evaluate these values, finding these values on the graph. So remember, if the value is in the parenthesis, that means it is an x value. If it is on the outside, this is a y value. So when x is -5, I have a -4. When x is 0, I have a +2. When x is 3, if I go up, I have an open dot, so I can't include that. I go down, I also have an open dot, so this one does not exist. All right, now for when y is equal to -5, if I go over to this part of the graph, I will have a +5. And then when y is equal to 3, looks like just the open dot, so this will be a does not exist. And last, when y is equal to -6, we have a +6. So these ones are not so bad. All right, example number 4. We also want to be able to evaluate algebraically when we are given a piecewise defined function and we are searching for specific values. This is where we need to use the restricted domain. Okay? So what I like to sometimes do is I like to number my functions. I know that I got 3 of them here. Okay? And what I am doing is I am looking between these intervals, okay, using these inequalities to determine where this value will lie. Okay, so if I have -12, I would look at my first one. Well, is -12 less than or equal to -4? Yes, -12 is less than or equal to -4. It would satisfy this restricted domain, so I would end up using the function here at number 1. Okay, because if you look, this -12 would not fit these others. It is not greater than 8, and it is not between -4 or -8. So then let's look at the next one, -4. Where would that lie? Would this be the first one? Well, if it is less than or equal to, it will be the first one because we are equal to -4. And if you looked at number 2, This one says x is greater than -4, so it definitely cannot satisfy the second function. All right, when x is 9, that looks like we're down here at the bottom, so that's going to be the third one. And 8, well, x is 8. It's not greater than 8, so that looks like we got to use number 2. And then when x is 5, looks like we are at number 2 again. And when x is -3, it looks like we are also at number 2. Okay, so now that we've identified which function to use, we're simply going to plug these values in and work them out algebraically. So this first function says we've got 4x plus 5. We are going to replace that x with a -12. So we got 4 times -12 plus 5, which is going to give me -43. Okay. I'm going to do the next one and have you guys complete the rest. So we're going to use number 1 again. So we got 4 times -4. And then we have the plus 5, and that is going to give me -11. All right, go ahead and pause the video right now. Complete the rest of these. Make sure you are using the correct function, and then come on back. All right, welcome back. So at x equals 9, remember if I'm greater than 8, that value is just 10. That's that horizontal line. When it's 8, the last 3, I'm using the second function, so I ended up getting 1, 7/4, and 15/4. Remember, do not let a fraction fool you. Sometimes it might not be a whole number. All right, very good. And then our last example, we actually have an application here. It tells us that our cell phone plan costs $65 a month, and then it gives us unlimited talk, but only 200 text messages per month, and there's also no data plan. That's very good. The internet is not necessary on your phones. After 200 text messages, it costs 15 cents per text you send. It wants us to write a piecewise function that models this scenario. All right, so how will we approach this? Well, we know that we have a piecewise function, so let's just do f of x since our function name was not given to us. And then we can draw our squiggly brackets. Okay, so what we want to do is we want to think about the restricted domain. This is a good way for us to start. Okay, we know that we have $65 a month for the plan, and that we have this limit of 200 text messages per month. Okay, so we know that from 0 texts to 200, we are within a fixed limit, correct? So that is our first restricted domain, because once we go past 200, that's when we actually have a different model for this cell phone plan. So let's go ahead and we'll leave a little bit of space. We'll write our restricted domain here. And we know that we are between 0 text messages and 200 text messages. Okay, we know we're going to have a variable, and we know we're going to have these, but we want to figure out, are we going to be using just less than and greater than, or are we going to have less than or equal to, greater than or equal to? So if it's $65 a month and we send 0 text messages, does that impact the original plan? Well, it's $65 a month regardless, and that's for the unlimited talk. And we do get these messages, and it doesn't say, oh, you have to send a text message. You might be one of those people that never sends a text message. So that plan can hold true for 0 minutes. Okay? And it says we can send 200. It doesn't say we go up at the 200th text message, right? So we can also include the 200 messages. It's just once you go after 200 is when the plan changes a little bit. All right, so for this domain, for 0 to 200 minutes, we know that the plan costs how much? $65 per month. Okay? So we are a flat fee at $65 a month. Okay. Now, remember, our domain is talking about the minutes and not the months. So regardless of, or I'm sorry, the text messages and not the months. So regardless, it is $65 a month unless we go over that $200 or 200 text message model. Keep messing up my words here. All right, so this is our first function right here. Now, it says after 200, okay, so does it give us a limit, you know, up to 1,000, 10,000? No, it just says anything after 200. So how can we model this? We know we included 200 in the last one, so we can't be 200 in this one. This is anything over 200, which means that x is going to be greater than 200. Okay, so this is our restricted domain for our model going over 200 text messages. So we know that we have the $65 a month fee. That is always included, but we're going to start charging 15 cents per text that we send. Okay, and if you remember the modeling from our equations unit, we can set this up. Okay, if I am looking for all of the messages past 200, so let's say I had 250, right? I would want to ask myself, how can I model this where I want to find out how many messages over 200 did I go? So if I'm at 250, how many did I go over 200? Well, it looks like 50, right? That one's pretty visible to the eyes. So how can I go from 200 to 50 modeling that mathematically? Well, 250, if I had minus x here, right, and then I could solve for x, but this one's pretty easy to do in our head. We're just simply subtracting that 200. Okay, so this is what gives me that model of how to find out how many messages, how many messages over 200. So this is going to be my however many messages minus the 200 that are in the original plan included in that 65. So if it's 15 cents per text you send, that is being added on to the monthly fee, and that is times per how many messages we are sending. All right, so now we have our fully modeled scenario. Boom, it is looking like this. And then if we wanted to ask, you know, what is the plan cost if I sent 300 messages, we could simply plug this 300 into this x here and solve, and then we would get that dollar amount. Make sure you understand how that works, because you might see a question like that in the future. All right, so this is all I have for you guys today. My apologies for it being so long. I was trying to really explain how to get everything done in this section. As always, reach out for help if you need it. Do the practice. It will certainly help you. And I'll catch you on the next one. Peace out.